In this section, we're going to look at transformations of graphs. For simplicity, we're only going to look at 4 types of transformations: the vertical and the horizontal slides, reflection in the x-axis, and an absolute value. Now, all these transformations do is change the position of the graph in the coordinate system. Starting with the vertical translation. A vertical translation happens when you add a constant to your function. So in this case, we have f of x plus c or f of x minus c. And the moves on these are representative of whatever the sign happens to be. So if you see f of x plus c, you're going to move up so many units. If you see f of x minus c, you're going to move down. Let's take a look at example 1. On example 1, we're given this function, and we are asked to move the function up 2 units, up plus 2, and then we're also asked to move it down 2 units. Starting with the vertical transformation up 2. I'll make this screen just a little bit bigger so we can plot our points. So using the red marker, we're going to take each of these units and we're just going to translate them up 2 units. Let's check our scale. Looks like our grid has a scale of 1. So starting here at 5 on the y-axis, we're going to move that blue dot up 2 units to 7. Now all we have to do on these freehand graphing problems is to get the major points down, where the graph happens to turn at a max or a min, or where the graph moves quickly from one point to another. So in this case, I'm just going to go down my graph, and at this location we cross the x-axis. So right here at x-axis, I'm going to move up 1, 2 units. There's a minimum here. I'm going to estimate my 2 units. There's 1 unit, there's 2 units. That's my minimum. I have another x-intercept at this point, so I'm going to move up 1, 2. Maximum at this point, up 1, 2. And you just continue on until you have the shape of the graph sketched out well enough that you can sketch it in with it translated 2 units up. Okay, so I think that's enough. And that's the translated graph f of x that's been translated up 2 units. Now, if we wanted to translate it down 2 units, we grab the blue pen. We're going to do the second part, f of x minus 2. We're going to translate it down back to the black graph, and we're going to translate each of these points that were on the original graph down 2. So 1, 2. I'm going to just take my minimum here. I'm going to drop it down. 1, 2. Once again, I'm estimating. This is towards the middle of that grid, and so I'm going to drop that down towards the middle, and then this one down towards the middle. My maximum, about right here. I'm going to move it up. Excuse me, I'm going down. I'm going to go down the grid. 1, 2. This minimum down, 1, 2, and then where the graph ends, I'm going to move it down, 1, 2. Okay, so then connect those points, and the blue graph represents f of x translated down 2 units. Alright, let's take a look at these graphs. Now you can do this part 2 of example 1 using your calculator if you wish. We can also do this one by hand. To look at it as our calculator, we're going to go to the y equals, we're going to hit our catalog, so second catalog, and it'll pull in our absolute value. Let me do that again. So that's how you get the absolute value in on your calculator. If we wanted to graph it to y equals, second catalog, enter, and it puts the absolute value bars in your y equals editor. And we are going to take the graph of the absolute value of x and we're going to move it up 2 units. Hit graph, and that's the translated function. I'm in a different zoom format. Let me hit the zoom button and then go to standard. And that matches what's on your screen for your calculator. Now, transferring from the calculator to the graph paper can be tricky. You can use your table function and plot points to get that translated graph. So I'm going to take these points on my table and I'm just going to plot them as best as I am able on this grid that's given to me. Checking our scale, we have a scale of 1/2, so it takes 2 units to get to our first marker of 1. So what we're going to do is we're going to be able to graph the point 0, 2. We can graph the point 1, 3. I'm over here. 1, 3. And the grid is too small for us to put any other points for this graph above 1, 3. So I'm going to go to the other side of the y-axis. I'm going to go to -1, 3. And once again, I can't go any higher on this grid and get one of those points on, so I'm just going to connect these 3 points into the shape of the absolute value. Now, if you wanted to work with the grid paper, what you would do is you would go back into our lesson from section 1.3 and remember the basic functions and what they look like. And the basic function for an absolute value, it goes through the origin and up and to the right on the right hand side, and then coming in from the left it goes down and to the right. So this is the basic shape of an absolute value. And if we wanted to shift this graph, this is g of x, excuse me, that's f of x. If we wanted to shift this graph up 2 units, then the next thing we would do is we would just take the points on the black grid and we would count up as best we could until we ran out of space on our grid. So showing that we end up in the same place, starting here at the origin, we go up 2 units, end up on that blue graph. Then over to x equals 1, we go up 2 units, 1, 2, end up on the blue graph again. Over to x equals -1, up 2 units, and once again we get the same graph as before. So you can use your calculator to check your graph, or you can use the calculator to generate the points that you need to graph on the grid. Now, there's an extra little bit on this example that asks you to identify the parent functions first. And this guy is the parent function. F of x equals the absolute value of x. And the one we just graphed is g of x, which is equal to the absolute value of x shifted up 2 units. The next graph we're supposed to work with is the square root of x minus 2. Let's do this one on the grid first and then go to the calculator. So on the grid, we need to remember what the square root of x, the parent function, what it looks like. So the parent function, the square root of x, starts at the origin. When x equals 1, y is 1. Check your scale. Make sure you're putting your marks on the correct grid. When x equals 2, y equals the square root of 2. When x equals 3, y equals the square root of 3. When x equals 4, y equals 2. So the basic square root function looks like this. So we're going to graph the square root function where we've shifted it down 2 units. So these 3 dots I've marked, I'm just going to take them and move them down 2 units. And I end up with a shifted graph that looks like this. So this is h of x equals the square root of x minus 2. If we used our calculator, clear out your absolute value function and find where the square root is on your calculator. It's right here on the x squared button. Hit second, x squared, type in your variable x, move outside of that radical, hit minus 2 and graph. Our function, once again, matches what's on the paper. And then if you wanted to graph from your calculator, hit second table and pull some values. Notice we have errors where there are negatives, and that's because you cannot have a negative square root. We have integer values at these places, and that's what I would plot. I would plot when x equals 0, y is negative 2. When x equals 1, y is negative 1. When x equals 4, y is 0. And I would not plot these decimals, since I can avoid doing that with these integers.